Welcome everyone. So before I actually kick off this video, I have a couple of questions for you. There are two. First, why 60% of you are not subscribed? And second, why do we don't have any females in the team? We only have some genders over here. All right, enough. Now, you want to get yourself in a big fish company like Tesla. What do? There are a couple of two platforms that are going to be helping you, LeetCode and HackerRank. And probably I'm going to do HackerRanks as well because these are interesting as well. LeetCode is more about the algorithm based, and HackerRanks is more like a practical thing, take JSON data from server and so on. So 67, let's read this because this question here was given by Tesla in a coding interview. Given two binary strings A and B, return the sum as a binary string. And that's pretty much it, the problem. A is 1, 1, B is 1, and we need to return 1, 0, 0. So first of all, I assume we all know how to read binary. If we don't, I'm just going to write a couple of things down, and I'm going to write this number. And in order for me to read the binary, it's actually pretty simple. I'm going to go take this binary code, and under each digit, I am going to write my decimal digits. So I'm going to write 0, 1, 2, 3, and keep in mind if I have 30 numbers here, like this, right? I'm just going to go 4, 5, 6, 7, 8, 9, 10, 11. As I said, we're just writing here the decimal point because we're going to be traversing our binary code into decimal. Now, I'm going to Control Z a couple of times just so I remove these. And in order for me to read this binary code, it's actually pretty simple. All I need to do is to take the following. 2 to the point of this thing over here multiplied by this thing over here. Then I'm just going to say 2 to the power of 1 multiplied by 0 because I have a 0 here. Plus, here's the interesting part, 2 to the power of 2 multiplied by 1 because now I have this thing over here. And finally, I'm just going to say plus 2 multiplied by 0 to the power of 3. Of course, this is going to be 0, this is going to be 0, this will be 0, and this finally is going to be 4, meaning that the binary 0100 is going to be equal to decimal 4. That's pretty much it. So in reality, what we need to do here is to actually add them. So let's try to add 1, 1, and then I'm going to add 1 over here. Now keep in mind we're working with strings, but in reality this is going to be the binary codes. And in order for me to perform this, I'm going to say 1 plus 1. This is going to be 2, but in binary we said that it's going to be 010. We can remove the O here, and it's going to be 10. And again, 2 is equal to 10 in binary because here we have 0, here we have 1. And in reality, in order for us to do it in decimal, we're going to say 2 to the power of 0 multiplied by 0 plus 2 to the power of 1 multiplied by 1. And this is going to give me, of course, 2 in decimal because of the mathematics. So let's Control Z's and remove these things. Currently, I'm going to have 10. Right? Because this is going to give me 2. Well, I am going to write 0 and I'm going to have 1 as a carry. That's something else that's pretty difficult to understand, I would assume. But if you take decimal math to binary, it's pretty much the same thing. If I have 64 plus 6, all I really do here is I see, okay, this here is equal to 10. And in the decimal point, everything from 10, I'm actually breaking into a carry. So I'm going to place the 0 down over here. And I'm going to have this one as a carry. So let's say carry is going to be equal to 1. I'm then going to say 6 plus 0 is going to be 6, but I have the carry. So the carry is going to come here plus the carry, and it's going to give me 70. And that's how I know 64 plus 6 is going to give me 70. The same thing is going to happen here. I'm going to write 0 because in binary, we break everything from 2. In decimal, we break everything from 10. In octa, we break everything from 8, and so on. Then I'm going to have this one over here that you see. I'm going to place it over here. And I'm going to get 2 again, which is going to be in binary 10. And again, I'm hitting this point where I need to take a carry. And that's why I'm going to be writing O. And finally, I'm saying O plus the carry, which is 1, is finally going to give me this thing over here. And in reality, I get this. If you want to think about it, let's say 011 plus 001. This here, as I said, let's calculate it. 0, 1, 2. This is going to be 1. this here is going to be 3. And of course, 3 plus 1 is going to give me the number 4. And that's how I achieve this 4 here as well. Pretty much the same thing. So let's actually see this in code, because in JavaScript is going to be a bit more different than it was with the C#. So the first thing that, and finally, when you actually have this, obviously you need to return it, yes. So I'm just going to create a result variable. I will be required to be returning a string, as you can see from this output over here. So that's why I'm going to be declaring the result as a string. Then I need to create the length of the first and the second strings, because that's what we're going to be iterating. And variable choosing is always difficult, but I'm going to say first length, that's going to be equal to a length minus 1. And then I'm going to say second length is going to be equal to, of course, the second string minus 1. Minus 1 because this is the terminator. The terminator. So I'm going to now create the carry. The carry is going to be starting at 0 each and every time when we actually start calculating something. We do not have a carry until we hit this break mark. As I said, in decimal, if I have 50, and I need to start right, 54 plus 3, this is not going to hit the carry mark because here I'm going to get a 7. And since I'm working with decimals, I'm not hitting this 10 and I will not be having a carry. So then I'm just going to say 5 plus 0 plus the carry, but the carry is going to be 0. In reality, we don't see that because we do it in our mind. And of course, we have the number 57. So 54 plus 3 is going to be equal to 57. We don't have any carries. And that's why I'm going to be starting the carry as a 0. Then I need to check if first length is bigger or equal than 0, or second length is bigger or equal than 0. Now, I don't want to do that because keep in mind that the first string here is longer than the second string here, meaning that if I finish with the first string, it doesn't really necessarily mean that I have the answer yet. So that's pretty much it, something that we need to keep in mind. Total sum is going to be equal to the carry. I always make the total sum to be equal to the carry first. When you do this in your mind, you don't really see it because you say, all right, 53 plus 54, right? And then you get 107, but you don't really keep a track about the carry. In the computer, we obviously need to think about that. So I'm just going to say total sum is going to be equal to carry no matter what. It's going to be equal to 0. Then we're not going to write it down. But always say total sum is going to be equal to the carry because otherwise we're going to be losing it. Now I need to check if first length is bigger or equal than 0. And if that is the case, I'm just going to say total sum plus equals the first string of this index minus the letter O. Now this here is actually pretty interesting. I am working with a string and I want to get an integer. How am I going to do that? You have always heard about ASCII, I would suppose. If you have not, let's say ASCII here. And I'm going to try to find it for you. So what is this? No, I don't need this. I had to prepare it, I guess. I think this is going to be working. Let me just put up a red or actually green color. Now you can see here that the ASCII character 48, right over here where the green mark is, and I'm going to type it down because you're not going to see it well. 48 is going to be equal to 0. Then I'm going to have 49, which is going to be equal to 1. And that is all I really need to understand. If I have, this is going to be the ASCII representation, so 48 as a number is going to be equal to a 0. And in order for me to actually get, let's close this now because we've already seen it. In order for me to get the actual number, I'm going to say 48 or 49, depends on the character, right? I have 1 here. For example, I'm taking this B1, it's going to be 49 represented in ASCII. Then I'm just going to subtract from that the letter O, which is going to be 48. And this is going to result in 1. Now, this is very interesting because here I have complete 4 bytes integer and I do not have a character now. In JavaScript, you cannot see this, but in C# you can see that pretty well. So if you want to get a better understanding of how this works, I would recommend my video, which is going to pop somewhere around here. I hope, if I don't forget, you can go watch that. It's going to be C#. Then I need to check if the second length is going to be bigger or equal than 0. And of course, I'm going to do pretty much the same thing, total sum. But I'm going to add not A, I'm going to add B, because this is going to be the second string, with, of course, the second length as a position. And of course, I'm going to subtract this character over here. Pretty simple, pretty straight. Now, keep in mind, if I have 1 here and 1 here, I'm going to end up with a 2. So that's going to be 1, 0, meaning that if I have a 2, I need to keep 1 as a carry. We have already talked about this. So in order for us to do it in code, I'm going to say carry is going to be equal to total sum. And if that is bigger than 1, I am going to say 1. If it's not, I'm going to say 0. So pretty much, again, if I have with green, actually, I don't like green. Let's go with red. Yeah, let's go with red because we need to, it's important. So if I have 1, 1, and then I'm saying 1 again here, I'm going to have a 2. In order for me to represent it in binary, however, 2 is going to be 1, 0. So I'm just going to be placing the O over here. And I need to keep a carry of 1. And all I really do is I'm checking, is total sum bigger than 1? If it is, then the carry is going to be 1. If it's not, then the carry is going to be 0. Pretty much straightforward. And of course, in the loop, we're adding it as well. All right, and the final thing we need to do, since we're working with binary, is of course say result plus equal total sum modulus 2. This is going to help me, and if we're working with decimal, of course, we're going to be saying 10 here. If we're working with an octa, we're going to say 9, 8, and if we're working in hexadecimal, we're going to say 16. Since we're working with binary, I'm going to modulus 2. The final part is actually to check, since both of these have different length, I want to know, am I still having a carry? Because I can have a carry at the end, and you can see this in the decimal points. If I have 9, 9 plus 9, 9, for example, you're going to see that this calculus is a bit different, and it's not going to be a two-digit calculus at the end. It's going to be 3. Right? So we need to keep track, do we have a carry? If I have, I'm just going to re-add it. And of course, I can say if carry is not equal to no, to 0, I'm just going to say result plus equal to carry. All right, pretty much that's it. The final part that we need to do is to write a function to reverse our string. And keep in mind that we need to reverse it because when I did the calculus, I didn't really show the fact that if I have a 1, I'm actually appending it to a string. So in our reality, where I had 1, 1, plus 1, and I showed you how we get 1, 0, 0, I didn't consider the fact that we're going to be adding it into a string. When we add it to a string, I'm going to be taking this 0, append it to a string, then take this, append it to a string, then take this and append it, and I'm going to end up having 0, 0, 1, which is going to be completely wrong answer if I return it. I need to reverse it first. And in JavaScript, it's a bit less of a struggle. We can just write a complete different function reverse, and I'm going to say string or str to reverse. Of course, what I need to do is to first split it, then I need to say reverse as a function, and then of course join. All right, and that's pretty much it. And final part is for me to return the reverse function with passing result here, because that is what string we're using to append the answers from the calculations. All right, and let's go submit, see if we can do it in the first try. All right, and there you go. This is the same solution as in C#, but this time written in JavaScript, a bit different. But again, if you want to see the full idea, I recommend you go watch the C# video. C# is a better language because you can just see what's in it, what is a string, and here you can just see let. And final part we need to be talking about, time complexity is going to be linear. We're not doing anything fancy. We're just having one while loop iterating through both of the strings that we're passing. And space complexity is going to be linear again, because here, when I do this, strings are immutable. So in order for me to mutate a string, I need to create a whole new one. So that's pretty much it. That's why it's not constant. Thank you for watching, and I'll see you in the next one. Bye.